Shit, bro, that's a lot of tens. Okay guys, so we are supposed to evaluate the derivative with respect to x of the square root of tangent of x plus the square root of tangent of x plus the square root of tangent of x, and so on forever. This is an infinite cave. I like to call this stuff caves because, well, those are not towers for sure. So an infinite cave of square roots of tangents. For God's sake, how are we supposed to solve it? Okay, so we would like to use a nice trick which kind of uses the fact that this is an infinite sequence of tangents, so that they will never ever stop. And so if we just kind of take out one of those tangents, it does not really change the value of anything. It just goes on forever, so it will make up for that lost tangent somewhere in the future, yeah? And so we can say that if I set some kind of a y equal to this entire thing, to this entire 10x plus the square root of all of that stuff, yeah? Then I can just as well say that y will be equal to the square root of tangent of x plus y. Because, well, y is just the square root of tangent plus the square root of tangent plus all the way up to infinity, yeah? Awesome, because you see, this is also just the square root of tangent plus tangent all the way up to infinity. Okay, that's lovely, because now what we can do is just square both sides, take this y to the left hand side, do some differentiation, and hopefully isolate the derivative in the very end. Lovely. So let's do it. What I'm gonna get after squaring everything is gonna look something like this. It's gonna be y squared equal to tangent x plus y. Now I can just move that y to the left hand side. I'm gonna get y squared minus a y equal to tangent of x, so that tangent of x. But now what I'm thinking, it's not gonna be quite comfortable for me to be, you know, differentiating this stuff and then trying to isolate the derivative and, I don't know, dividing by y minus 1 and stuff like this. It's not really my thing. However, I'm just kind of thinking, how can I complete the square here so that I can once again take the square root, however leaving all of the y's here on the left hand side of this equation. Well, so that I don't have y's in varying powers there, yeah? Well, if I were to add myself a quarter on both sides of this equation, I'm gonna complete the square. I'm gonna complete the square nicely on the left-hand side, yeah? So, well, let's go on and do it. I'm gonna be left with y squared minus y plus a quarter equal to tangent x plus a quarter. However, now pretty lovely, just going on and taking the square root of this stuff is gonna give me y minus a half being equal to the square root of tangent of x plus a quarter. To square root of tangent of x plus a quarter. Man, I should have put those grid lines here on this black screen. Okay, tangent of x plus a quarter. But now, well, there is no problem for me to just differentiate both sides with respect to the x. And so what I'm going to be left with is just y, the derivative of y, which I was looking for, the y prime, which is going to be equal to, and now what's the derivative of the square root of tangent x plus a quarter? This one shouldn't be too difficult. Well, by the chain rule is gonna be 1 all over double the square root of tangent of x plus a quarter. So the derivative of the square root of x with respect to stuff that we have inside of this square root, and now have to multiply everything by the derivative of tangent of x plus a quarter. Derivative of the quarter is a 0. What about the derivative of the tangent? Well, using some quotient rule and interpreting tangent of x as sine over cosine, we're gonna end up with that this thing is actually equal to secant squared of x. And so our derivative we're looking for is just the secant square of x all over the square root of 4 times the tangent of x plus 1. Oh, and don't forget the plus c. Okay, so I really hope you guys enjoyed this short video. If you did, well, then like and subscribe to my channel, because then you're not gonna miss out on anything I'm gonna be posting in the future. And actually, I post every single day, or even twice a day sometimes. So there's a lot of stuff to miss out on. Well, see you next one. Bye.